In stats, we started chapter 6, matrices and determinants, and we are looking at a system of 3 variables with 3 equations, and we're looking at an alternative way to solve the system with matrices. So the first step is we need to make what's called an augmented matrix. You take the coefficients and the constant on the right of the equal sign, and you write a row like that. So just the front numbers and the constant right of the equal sign. So these rows should match each equation. All right, that's step number 1, augmented matrix. Next, we have the goal of making this look like this. We need to rearrange things, and we're allowed to flip rows, add or subtract rows, or multiply a row by a number. We need to go column by column, left to right. So I'm starting by addressing this column, and then once I get that one to look like that, then I move to this column, and I'm trying to make it look like this. All those lowercase letters in these letters, those are just any number. We don't really care about those numbers. What we care about is we need a diagonal of zeros and a diagonal of ones, and we need zeros underneath those ones. That is the key. It's called the row echelon matrix, and the process is called Gaussian elimination. It was this guy Gauss that came up with this concept. So let's give it a shot. I'm going to give myself lots of room, and what I'm going to do first is flip row 1 and 2. Because I noticed that row 2 has a 1, and that will give me a 1 in the top left, which is what we need. And then just copy row 3. All right, we got one of the 6 numbers addressed. I bet this one right here is going to become something else in a minute, because I need to now look at this, and I want those to become zeros. So I'm going to write instructions in between each matrix that I create. So first off, we are not going to change row 1. So go ahead and leave a blank space to write instructions and copy row 1. Now we need to make that 3 become a 0. So let's multiply row 1 by -3 and add it to row 2. So you're allowed to combine rows, adding and subtracting, and multiply a row by something. We're doing the combination of both. So I'm going to multiply row 1 by -3, add it to row 2, and that creates a 0 right here. That was the whole goal of the blue writing right there, was to create that 0. Now, unfortunately, it changes a lot of other things, like the 1 to the right, this 1 right here, changes. So another thing is my eyes are right here, and the result goes over here. All right, so be careful with that. All right, so -3 times 1 is -3. Add it to 1, and we have -2. Negative 3 times 2 is negative 6. Add it to 2, and we get negative 4. Negative 3 times 19 is negative 57. Add it to 31, and we get negative 26. And there's one row done. Now I need to make this 1 become a 0. So what if we go row 3 minus row 1? That'll be 1 minus 1, 3 minus 1, 2 minus 2, and 25 minus 19. All right, we're making progress. Column 1 is done. Let's copy row 1 because we are done with that. I don't want to alter that. For row 2, I need that negative 2 right here to become a 1. So I'm going to multiply. Why did I write that in red? Let me rewrite this so these instructions stand out. Sorry. All right, I want that negative 2 to become a 1, so I'm going to multiply row 2 by negative 1/2. And that'll create a 1 where that negative 2 is. Like that. For the bottom row, this concept right here really bothers people. Again, I am looking right here right now. I'm not looking at the matrix that I'm creating. So I can use these two numbers to create a 0 right there. I think a lot of people get lost in all this and they start looking only right here. But what we're doing is we're using the matrix I have circled right there to create a new matrix. It's a pretty clever concept that Gauss did. So I'm going to erase all that because it's very messy right now. And what we want to do is add row 2 and row 3, and we get 0 plus 0, negative 2 plus 2, that was the goal right there, negative 4, and negative 20. And look at that, we are almost done. Copy row 1, copy row 2. All right, for row 3, I need that negative 4 to become a 1. So let's go negative 1/4 times row 3. And we get 0, 0, 1, 5. Now, how in the world is this useful? Well, row 3 represents the z's. So that means 0x plus 0y plus 1z equals 5. We know what z is. 0x plus 1y plus 2z equals 13. And lastly, x plus y plus 2z equals 19. So now I can back substitute and figure this out. Right here, we know y plus 2 times 5 is 13, so y is 3. This equation, we know x plus 3 plus 2 times 5 is 19. That means x is 6. All right, in the next video, I'll just do another one. See y'all later. Bye.